In this part, I'm going to show you how to test capacitors. Now, I do have other videos that I've done testing capacitors and stuff, but this is using a digital multimeter that I'm showing all the functions. But the one thing I did want to show and point out, if I can zoom in, is I wanted to check out these capacitors. Do you see something different? Well, if you look and see the blue one at the top, you'll notice that it's got the negative symbol. And it's pointing this direction. And you can see the little metal tip that sticks out. But look at the one on the bottom. It shows a positive symbol. It's pointing to the positive lead and not the negative. Now, some of these you will find that do this, but not often. So when you do use these capacitors, double check to make sure that you're connecting them properly in the circuit, because polarized capacitors can be damaged if they're connected wrong. So you want to double check. Now, the first thing we need to do is set your digital multimeter into capacitance. It'll either say CAP or it'll have the symbol for capacitance. And if you've seen my other videos pertaining to capacitors, you'll understand what the symbol looks like. Now, to test these, it's very simple. I usually ground out my test leads. That way I can help this reset. Now, all you have to do is hook up your connectors. Move that one out of the way. Hook up your connectors. And wait a few seconds. Because it has to be able to measure. Now, it's up to 19. The capacitor is a 100 microfarads. So it may take a minute. The larger these are, now some of these digital multimeters can go up to 200 microfarads, such as this one here. Now, you can see that it changed to 137.1. So it's fairly close. Most of these capacitors are within 10 to 20%. So this one here is like a 20%. And there you have it. This is how you test them. Just be sure that they're discharged using a pair of pliers or something, an insulated pliers, especially if it's a high voltage, because the meter provides power to the capacitor to measure it. And if there's voltage already in the capacitor, it can severely damage your test meter. Okay, here in this part, I'm going to show you about frequency, or hertz. Now, if you were to plug your test meter up to your outlet, your power outlet, it will tell you the cycles per second that your alternating current or your household current is fluctuating, or how often it's changing polarities. Normally, here in the U.S., it changes right around 60 hertz. In most countries, it goes around 50 hertz. Well, let me give you an idea of what this is actually doing. Now, if you look at the board, I have a 555 timer. It's that little square chip in there. Now, I'm not going to explain everything about it right now. I have this set up for frequency. It's going to emit pulses so many times per second. That is what a frequency is. The number of pulses that's being counted within 1 second. Now, alternating current goes from 0 to positive back to 0. and then from 0 to negative back to 0. That is one complete cycle. When you're doing with DC, the cycle goes from positive to ground, or 0 volts, which in this case I have it set up. Now, as soon as I turn the power on, watch my display. I have my display set for frequency. Down here on the bottom, you'll notice it'll have HZ on there. That stands for Hertz, or frequency. But Hertz is just saying cycles per second. Let me turn the power on. Now, as you can see, it's showing 1.182. Well, let me hit the hold button. Now, as you can see, it's not moving now. That's what the hold button was for. Now, look closely. Down here at the bottom, you'll see that you have the K. That's a K right there. Over here it says HZ. That's for Hertz. Now it says 1.184. There's a K, so that means it's 1.184 kilohertz. Or it's 1,184 cycles per second. So when you look at these meters, check down there and it'll tell you what the range is. Right now it's showing 1.184 in kilohertz. Now, if I was to change it, let me turn the power off and let it drain, because you're not supposed to change these while there's current still present, and you'll see because it'll hit to 0. Now, let me change my little capacitor here and put a little bigger one in there, because the capacitor has to do with the timing cycle that I've set up. Now, it was moving at such high rate, you couldn't tell by the LED blinking. It stayed on. And it was actually providing 1.1 or 1.2, however you want to look at it, cycles per second. It was happening so fast you couldn't see it. Well, the timing cycle was pretty fast. Now I'm going to slow it down. Let me turn the power back on. Now, have you noticed something different? Now you can actually see the LED blinking. Now, if you look to the right, you'll also notice, or to the left, I'm sorry. It's kind of hard when you're doing this upside down to get your directions right. Now, you'll notice there's 1.897 or 8.98. It would change on me. But there, I'll freeze it. Now, look at the bottom. You'll notice that it doesn't show any kind of symbol. It only shows Hertz. So it says 1.898. Okay, that's 1.898 cycles per second. It's doing this at almost 2 cycles per second, which you can clearly see that the LED is flashing. Now, let me show you what's going to happen if you decrease the timing cycle. Let me turn the power off. Gives it a couple of seconds so it can discharge. Okay, now let me change my capacitor, put a little bit bigger one in there. Now I'm installing a 100 microfarads. The first one I had in there was this one here. This one here was only a 0.1 microfarads. This one here was a 47 microfarads. And now this one here is a 100. Now, watch what happens to the cycles per second. Now, as you've noticed, it's dropped. It's just under 1 cycle per second. Now it's 0.76. And notice down here again, it don't have any other force symbol like a K or an M. So it's 0.707 cycles per second, or 7/10 of a cycle per second. And as you can see, my LED is flashing slower. Well, the frequency comes in handy when you're building in your house, if you want to know what the cycles per second is. If you're building a timing circuit like I did here, you'll see a lot of these in switching power supplies and tone generators. And I'll show you some other things that you could do with this 555 later on in other videos. Now, in this part, I'm going to show you what duty cycle is. Now, it's similar to frequency in hertz like I demonstrated a few seconds ago, but it's slightly different. And I'm about to show you how it's different. Now, my meter is still set on frequency, as you can see down here. Well, all I got to do is press my button over here to switch between hertz and percent sign. That's duty cycle. Now, once I pressed it, now you'll notice the icon changed. It now shows a percent sign. Now, the duty cycle represents how long a pulse is positive before it goes to zero. In other words, when the pulse comes on, you'll see, now it says here 66.2. Okay, well, do you see anything different? Well, you can't tell by the light. Now, remember, this is the same capacitor as I used before. Now, if I was to switch it, it's showing it's running at 1.189 kilohertz, just over 1,000 cycles per second. So, what does this duty cycle represent? Well, it means that the pulse, this LED right here, is on 66% of the time during the cycle. This is what they mean by duty cycle. Here's an illustration as to what it actually looks like. With this illustration, I can show you what duty cycle refers to. Now, as you can see to the left, I have the icon for my LED when it's on and the LED when it's off. Now, the pulse that you're looking at is actually what you're seeing from my timer. Now, the time on is when the LED is on. The time off is when the LED is off, as you can see in the pulse. The total time is when is the same, or when time on is added to time off. This is the complete cycle. For the moment it turns on to the moment it turns off, and then it comes right back on. That's one whole cycle, as you can see here in this illustration. Now, duty cycle is the percentage of the amount of time that the LED or the pulse is turned on compared to the time that it's turned off. And duty cycle is just time on, the period, which these can be measured in microseconds, divided by the total time of the entire cycle. This is just what they mean by duty cycle. And when I do switching power supplies and stuff like that, then I'll give you a better description of how this is actually working. Now, see how it's blinking? If you look to the left, you'll notice that the meter is saying that the LED as you can tell, is being on 67.3% of the time. That means it's on over half of the cycle. Now, as you can notice, watch it closely. When it goes off, count how long it's off. And then when it comes on, count how long the LED stays on before it goes off. And if you'll notice, the off cycle is shorter than the on cycle. This is how duty cycle is calculated. Now, let me turn the meter on. You want to plug your thing in, like I have here. Now, the adapter here also has a positive and negative connector. So you want to make sure that you plug it in correctly to your meter. Now this, I have the adapter plugged in. And now I need to turn on my meter. Now the first one I'm going to do is a Fahrenheit. As you can see here, I got two functions. I got the Fahrenheit and Celsius. Well, using a thermometer or the temperature adapter, it doesn't matter. It's whichever you want to use. You can use Fahrenheit or Celsius. Now, I've got this right here just out in the open air. Just like that. Now, if you'll look, it shows that it's 74 degrees in the air. This is my ambient temperature. It's 74 degrees. You'll also notice down here at the bottom, you'll notice down here in the bottom that it has an F. That means you're on Fahrenheit. Now when you change it to C, it'll also change to C. And it shows you the difference. For Celsius, it's 23 degrees Celsius in here. And in Fahrenheit, it's 75 degrees Fahrenheit. Well, this is how the temperature works. Now, I like to use this on resistors and transistors, regulators, anything that's going to dissipate heat, because it gives me an idea of how hot something is, especially when it comes to transistors, because they can only reach to a certain temperature before they begin to fail. Well, let me turn the power supply on. And yeah, if you notice, I still got my timing circuit, my oscillator on here that I showed earlier, which is okay. I mean, that's to mainly let you know the power's turned on. Now, I've got it pulling current, which is only 50 ohms. So it's going to pull right around 3/10 of an amp. And it's starting to warm up. Now, I can set this on top. Notice how the temperature is going up. I've got it up to 100 degrees now. This is why it's a good way to have it, because this way you can completely monitor a component to make sure that it's within its safe levels. Now you can leave this on for a few minutes. Now we've already calculated the wattage on this thing, and it's well within its limit, and it's picking up right about 5 watts. Which is real safe. I mean, it's only going to be 10 watts is maximum, but 5 watts, you know, it can safely radiate the heat from it, from pulling the current. Yeah, let's check the temperature now. Now you can see it rapidly going up. It's up to almost 130. Yeah, there we go. We made it. Now, I'm going to leave this running for a few minutes, and we'll get back to see what it's doing. Well, we're back. It's been a few minutes that I've had it going to let it heat up. Now, as you can see, my meter has gone up to 199 degrees Fahrenheit. Well, now it just reached 200. Now, this is why it's so handy to have one of these little thermometers around, especially when you're doing with power supplies and high current, because you want to make sure that your component doesn't get too hot and burn out. Now, because this resistor is pulling just under 5 watts, it is safe enough for it to dissipate the heat. Now, anything going higher than 10 watts, then you're going to eventually burn out the resistor or the component itself. But as you can see here, and you can probably put your fingers over, you can feel the heat radiating off of it. But that's all it does. This is one of the most helpful functions I like about this meter, is because I can check to see if a component is overheating. Here, for the final part, I'm going to show you how to measure amperes using one of these digital multimeters. Now, I've got my power coming on this side. This is my negative side. This up here is my positive side. Now, these little rails right here, they're connected together up to this point. So I've got me a little jumper here so I can make this a complete power strip. And I've done the same thing up here. I made this row right here a complete power strip. In order to measure amperes, the cert meter must be in series to the power supply. In other words, since this is my positive, this line must go through the meter first, into the load, or into the rest of the power supply, back into the ground, going into the power supply. Now, this also works with AC. You have to put the meter where the current goes through the meter to your load. And DC is the same, through the meter to the load. Here, I'll give you a demonstration. Let me remove this jumper to where I can separate it. Insert my test lead. And then insert my next other test lead, my positive. Now, as you can see, the power will come from the power supply into my test lead, through my meter, back through the black test lead, and continue on into the resistor load. This is how you connect your test meter or your ammeter in series with your power supply. Now we can measure how much current that this resistor is providing or drawing. So let me turn on the amps. Now, if you're not sure how many amperes you're going to be pulling, you should start out using with the whole amperage, which you can go up to 10 amperes. Now, what happens is, as the current goes through, the test meter calculates how many electrons are passing through it per second. Now, if you have like a 0.1 or 0.2 or something, then you can knock it down to your milliamps. And then if you're still small enough, you can go down to microamps. Now, I hardly ever use anything with microamps. Usually it's either amperes or milliamperes. Now, I've got it set up. My test meter set to 0. Let me turn the power supply on. Now, the power supply is on. Now, as soon as I connect the resistor to the power, watch the ammeter. Now, as you can see, I'm pulling 0.28 amperes. That's like almost 3/10 of 1 amp. Now, what happens if I add another one? Let me get my test leads out of the way. Now, if I add another one, watch what happens. It goes up. Now we're up to 1/2 of an amp. Well, let me add a third. Now we're up to 0.81. We're just 2/10 of an amp shy from pulling 1 amp. Now, since I'm above 500 milliamps or 0.5, now I cannot use the milliampere. Now, as you can see, I've got my test leads switched. The positive is on this side for the 10 amps instead of over here. Now, with this one, if I'm not sure, I can use the 10 amps to get to where it's at. And if it's below, say, 400 milliamps, then I can switch it down to milliamps to get a more precise reading. And that's pretty much all there is. Now, let me add the fourth one here, the fourth resistor, and watch what it does. Now we're over 1 amp. We're pulling just a fraction over 1 amp now. 1 ampere. Now remember, the current is going through the positive, to my positive lead, to my test meter, and then back into the ground going through my resistors. This is how you use the ampere setting. Now, if you're not sure, start with the ampere. And then you can work your way down to the milliamps if it's below 400 milliamps. And then you can work your way down if it's below a milliamp. And then you can go down to the microamps. And this is basically all there is to measuring current and amperes. Just be sure that you do not go over your tester's limit. This one here is a 10 amp limit. Some of them can go as high as 20. But this is how you mostly use the meter to measure amperes. This concludes this two-part video of digital multimeter tutorial. This video was presented by ES Repair with your host, Mr. Fixit. You can find part 1 and other videos on our channel by clicking on our channel's name, ES Repair. Or you can find us at www.youtube.com/user/ESRepair. If you like this video, be sure to subscribe to our channel to receive the latest updates and activity from our channel. Thank you for watching.